Hello, fellow citizens of Earth. We hope that you enjoyed your break, but now it's time for us here at Station 204 to help you dive back in to this week's space traffic. First, we're heading to India's Satish Dhawan Space Center, where a polar satellite launch vehicle lifted off on May 22nd at midnight Universal Time, lofting the 615-kilogram RISAT-2B satellite into a 557-kilometer orbit inclined 37 degrees to the equator. This particular polar satellite launch vehicle was in the CA configuration, meaning core alone, eschewing the usual 6 solid strap-on motors attached to the first stage. RISAT-2B will use X-band radar imaging to resolve structures and features on Earth's surface. Because the satellite uses radar, it can take images in all weather and lighting conditions. Then on to China, where on May 22nd at 22:49 Universal Time, a Long March 4C rocket blasted off from the Tianwan Satellite Launch Center in the Shaanxi province. The payload was Yaogan 33, a military satellite. Social media posts from China showed a twisting contrail in the skies above the launch site, and Chinese media agencies eventually confirmed that the third stage of the Long March 4C launch vehicle failed and Yaogan 33 did not make it to orbit.
3, 2, 1, 0, ignition, liftoff.
Coming back to the United States, a SpaceX Falcon 9 lifting 60 of the company's own Starlink satellites left Cape Canaveral Air Force Station's Space Launch Complex 40 on May 24th at 02:30 Universal Time. Booster 49, on its third flight, separated and performed the now standard but always spectacular turn and burn, while the second stage continued to orbit, with Booster 49 successfully landing on drone ship Of Course I Still Love You. Once reaching 440 kilometers and an inclination of 53 degrees to the Earth's equator, a unique separation of the Starlink satellites from the upper stage occurred. Individually, each satellite weighs 277 kilograms, contains its own electric propulsion system, and will test out SpaceX's satellite internet constellation ambitions. Let's flash on over to Russia, where on May 27th at 06:23 Universal Time, a Soyuz 21B sent the GLONASS-M navigation satellite on its way from Plesetsk Site 43. A few seconds into ascent, lightning struck the booster, but there was no need to call SCE to AUX, and the Soyuz 21B continued, with the Fregat upper stage taking over and successfully placing the 1,400-kilogram Russian government satellite into a near-circular 19,100-kilometer high orbit at an inclination of 64.8 degrees to the Earth's equator. As per the Defense Ministry's nomenclature for satellite names, it will likely be redesignated Cosmos 2534. Now we're going south for a holiday at the Baikonur Cosmodrome Site 239, where on May 30th at 17:42 Universal Time, the first launch of a Proton rocket this year occurred, specifically a Proton M with a Briz-M upper stage, carrying Yamal 601, a Gazprom Space Systems communications satellite. The 5,400-kilogram craft was lofted into an elliptical geostationary transfer orbit, where its own onboard propulsion system will circularize its orbit and begin to provide C-band and Ka-band coverage of Eastern Europe, Russia, Central Asia, the Middle East, and parts of Southeast Asia. In our last bit of traffic, after 29 days on station, SpaceX's Dragon C-19 spacecraft undocked from the Harmony module's Nadir port, June 3rd at 16:01 Universal Time. This was Dragon C-19's second flight to the International Space Station. Once away at a safe enough distance, Dragon fired its engines, separated from its trunk, and began atmospheric re-entry to a successful splashdown in the East Pacific Ocean at 21:52 Universal Time. It returned 1,900 kilograms of cargo and scientific results. Now, that was quite a few launches to have to go over, and at present there's a lot of companies that are trying to build launchers as well, and Northrop Grumman's Omega booster is one of those. Aerospace is a field that's not for the faint of heart, especially as a designer. It's littered with the shrapnel of rocket parts and debris of ideas that were expected to change the game but didn't. Northrop Grumman made some shrapnel of its own on May 30th during a test of the Castor 600 solid rocket motor, which is currently designed as the first stage of their intermediate lift rocket, Omega. Mounted horizontally on the test stand in Promontory, Utah, the former stomping grounds of Orbital ATK, who Northrop Grumman purchased in 2018, the Castor 600 was heated to 32 Celsius to give it a little extra performance during the test, and it was set to burn for just over 120 seconds. All appeared to be going well until approximately 118 seconds into the test, when the Castor 600 appeared to cough out a good wad and destroy its nozzle. Now, with over 700 channels of telemetry being recorded, Northrop Grumman has excellent data to precisely determine what the problem was that caused the anomaly. Counterintuitive to what most folks think, this is a pretty good thing when the anomalies are happening on the ground, like SpaceX's recent Super Draco incident. You want these kinds of issues to be handled here, and with a fully instrumented system, and not in flight. And this is why we test and test. And now I'll be handing it over to Jade, who's going to tell us a little bit about how we test new ideas to make energy here on the Earth, and how the cosmos may be able to help.
Oh, plasma, the seductively mysterious fourth state of matter that dominates the universe and that we as humans have very little experience with. That is, until now. Kinda. This highly unstable, electrically charged fluid that comprises the makeup of stars has long eluded scientists due to how difficult it is to produce and maintain it. However, scientists in France and Ireland have made a major discovery about how it behaves in one of the most extreme environments in our solar system, the Sun. Using a large radio telescope in France and UV cameras on NASA's Solar Dynamics Observatory, they were able to study how plasma becomes unstable in the solar atmosphere, which can soar to as high as 2 million degrees Celsius. By using both space and ground-based equipment, they were able to image radio pulses emitted by the plasma for the first time ever and gain a deeper understanding of its behavior. You see, the matter that we're familiar with typically comes in 3 flavors: solid, liquid, and gas. However, the most common type of matter we see in the universe is the one we're not so familiar with: plasma. This elusive fourth state of matter occurs when a gas gets superheated to the point where its electrons break free from their atoms to form an ionized and conductive fluid. Despite it being so prevalent in the universe, it is also the least understood, and for good reason. It's extremely difficult to produce plasma in a lab due to the extreme conditions it needs to form. In order to fuse 2 hydrogen atoms, for example, you would need temperatures of at least 100 million Kelvin, which would vaporize any materials used for enclosements. Thus, some sort of confinement technique, such as a strong magnetic field, would have to be installed. Therefore, we use the Sun as a naturally occurring lab to see how plasma behaves in conditions too extreme for Earth-based labs to recreate. So why even study a form of matter that's seemingly irrelevant to our everyday lives? Energy. By seeing how plasma behaves in the Sun, we can learn more about how it behaves here on Earth, and we can use this knowledge to apply towards nuclear energy generators in the form of magnetic confinement fusion reactors. These are a safer, cleaner, and more efficient alternative to fission reactors, which break atoms apart versus fusing them together, and also uses radioactive fuel like uranium to power them. And if you've been watching Chernobyl, you'll already know the inherent risk associated with that. Although we're still decades away from developing a functioning fusion reactor, the demand for a clean, efficient energy source will only continue to grow as energy demands skyrocket, meaning it's probably best we figure out a solution sooner than later. Plus, understanding how the majority of matter works in the universe never hurt anybody, right?
And now for your interplanetary weather forecast, here's Dr. Tamitha Skov.
Space weather this week is definitely picking up a little bit. As we switch to our front side sun, you can see old regions 2740 and 2741 rotating back into Earth view. Now, they're not the powerhouses that they were the last time we saw these regions, but they are managing to boost the solar flux for amateur radio operators and emergency responders. And it looks like we do have a stealthy solar storm launch from somewhere in around these regions that's now headed towards Earth. And it could give us a bumpy ride easily over the next next few days. Now, as we switch to our backside sun, you can see those regions in Stereo's view, and they're beginning to leave Stereo's west limb. But if you look behind it, you don't really see anything else. So that means that once these regions rotate across the Earth-facing disk and disappear behind the backside of the sun, it looks like the space weather is going to return to being pretty quiet. Look up in the sky. It's a bird. It's a plane. No, it's just Starlink. No doubt you have already heard the news about the first 60 members in the SpaceX satellite train, which will ultimately be a 12,000 satellite constellation aimed at giving us fast internet coverage all over the world. Since their launch a few days ago, you can see these shiny new low Earth orbiting satellites like little fireflies in space. And they'll be especially visible just after dusk and just before dawn, when they will be lit by the sunlight, but your sky overhead will still be dark. But don't expect this shine to last. Expect their brightness to dim slowly as these satellites are now dealing with a hostile space weather environment that will dim their shiny coats over time. And this is just the first of many space weather challenges this budding constellation will face as the sun wakes up and begins firing all sorts of solar storms at Earth. No doubt Starlink will face issues with communications both to the ground and from satellite to satellite as they contend with this new kind of stormy weather. They could even be pushed out of their orbits due to the effects of space weather, so we shall see what the future brings. One thing is for certain, we are witnessing the dawn of a new era in space-age communications, and it's fantastic. But it's one in which space weather has now become your weather. For more details on this week's space weather, including when and where to see aurora, how GPS will fare, and what's in store for emergency radio communications, come check out my channel or see me at spaceweatherwoman.com.
Thanks for watching Space News this week. And before we officially wrap up, of course, we always want to thank our citizens of tomorrow. You folks are what helped make this show possible. We would not be able to do any of this or provide any of this for the world without your help. So if you'd like to contribute, if you got something out of the show, you can head on over to patreon.com/TMRO or subscribestar.com/TMRO. And if you'd like to contribute, but you can't do so financially, that's A-OK as well. Head on over to community.tmro.tv and you can find out a multitude of ways to contribute there as well. And if you are a citizen contributing via Patreon or Subscribestar, we're going to have a hangout for you this weekend in lieu of a live show. So stay tuned for more details about that. You're definitely going to want to tune in because you get to hang out and you get to hear new ideas, and it's pretty darn exciting. And that's it for this week's Space News. Until next week, keep exploring. We're on the internet. We don't have friends. We make a show. We're too busy for friends. Either way, you're watching me on the internet. Hello, I'm in your house. You really should clean up.